Imagine you and your best bud are playing Minecraft. You have built an intricate and carefully engineered railway system. But one day there's a misunderstanding in communication or timing, and now both you and your friend are barreling at each other in minecarts at dangerous speeds. Your Minecraft lives flash before your eyes. All that is left to think about is at what position will car A and car B collide. What else can you do in this moment besides solve the position of your inevitable collision? We will be releasing two toy cars 2 meters apart from each other, with a 1-second delay between each one. Car A will be traveling with a constant acceleration. Car B, on the other hand, is traveling at a constant speed with an acceleration of 0. Using meter sticks, a toy car, a fan-powered car, and an iPhone, we determine the position at which the collision would happen. Car A will be released 1 second before car B.
First, we filmed each car separately in order to calculate their separate initial and final velocities as well as acceleration. To calculate velocity and acceleration, we used data that we collected from the videos and kinematics. Car A traveled 2 meters in 7 seconds, and using kinematics, we found that its acceleration was 0.048 meters per second. Car B traveled 2 meters in 4 seconds. Using kinematics again, we found that its velocity was negative 0.7 meters per second, with an acceleration of 0. Its velocity is negative because in our experiment, we set it such that car B is traveling in the negative direction. In order to find the equation for each car for the position time graph, we plugged in the data and used a linear regression function and the quadratic function in our calculations. For the velocity time graph, we use the slope, which is the acceleration for each car, to find the equation. In order to find the collision point, we set the equations from the position time graph equal to each other and use quadratics to solve for x, which is time. Then we plugged x back into the function to solve for y, which is position. We found that cars will collide at time 3.02 seconds and position 0.59 meters.
In the position time graph, we can tell by the slope that car B has a constant velocity and that car A has an increasing velocity. We can also see the direction the cars are traveling in and the point that the cars will collide, which is the intersection point on the graph.
Let's see how accurate our calculations were.
When we tested for the real collision point, we came across a few challenges. The first being that we had to use a different fan for car A and that the batteries in car B were dead. We did find the same model of car to replace car B. However, some discrepancies were most likely caused by this. The actual collision point was at 0.63 meters at time 4 seconds. This is close to our prediction, but not exact. Some experimental reasons for the discrepancies may be friction, air resistance, and of course having to change fans and cars.